Okay, so we've talked about the fact that integration. What? You can't see. You can't see anything. All right. So what hilarious. Maybe it's age. Every other class loves it. So they can see.
I think it's just
Not age. No, definitely not. Okay. So we remember that. I hope you remember that if you've got a graph and you've been given 2 points, so for example B and A, if you were integrating it between those 2 values, you're finding the area underneath it. Yes. So sometimes they're going to say, okay, well, what about the area in between 2 functions? Okay. So it's going to be a similar situation. But what you're going to think of is like, well, how would you find this shaded area naturally? Well, you would find the area of the whole thing and find the area of the other thing and subtract one from another, yes? Mm-hmm. So you find the area from the red graph. So that's the integral between B and A for the red one, yes? Find the integral underneath for the underneath. It's always underneath, yes. And subtract one from the other. So we would find the integral between B and A of gx. Subtract the integral between B and A of fx. Now, which one's g, which one's f? It does actually make a difference, okay? So you need to notice here, she says optimistically, that the g is the one on top, okay? You probably, if you haven't got a diagram of it, you probably need to know a little bit about functions, or you need to use your knowledge of functions to decide which of your functions is going to be on the top and which one would be underneath. For this particular example, okay, well, no, not for this one, okay, for our actual example, and we've got a positive parabola, so we know that this parabola would look like this, yes? And we've got a negative parabola, so we know this one's negatively sad, so this one would be the one that's on top. In other words, this would be our gx. Does that make sense? Because I used my understanding of functions to know that if something's negatively sad and something's positively happy, if there is an area between them, which there's got to be, if they've asked us to find the question on it, it must be that this one is on top. Yeah. Okay. Now backtracking a little bit. So obviously we could work out each area separately and subtract them, or we could subtract one function from the other and then just find the integral between that. Okay, so we would just do gx subtract fx and then substitute values in. I'm going to go through, so it's all written in here. You may want to add some extra words, maybe a little step, I don't know, but most of it is pretty much here. So here's this diagram here. So, the lines are pretty faint, aren't they? Okay, so this is my gx, because that's the negative x squared plus 2x plus 10. And then this is my fx. Oh, I've just gone straight through the plus. And obviously we want the area in between those boundaries. Okay? So, if it hasn't said so in the question, and it doesn't actually say here, first of all we need to find where those 2 coordinates meet. Now, one would hope, and to be honest, most of the questions I have seen recently, in fact most of the time, it's on the calc paper. Okay, how do we find points of intersection using our calc?
You just do it. Just do it.
Just do it.
How do you use the parabola thingy and find intersection? It makes the lines on your.
Okay, so you would sketch these on your WhatsApp? Sure, okay. So as long as you're all comfortable using your GDCs to do stuff like that, so you would input one function input the other function, graph them both, and then you can see where they meet. Yes, so you go for the calculate where they're meeting. Yes. Otherwise, you would equate these two functions, okay, because that's where they're meeting. You'd rearrange it and solve for that. Either way, however you do it, however you choose to do it, but you just need to be comfortable to find points of intersection. In this case, we've got the values of -2 and 2. Okay? Do you care how it was done? Do you want to do a quick equation or no? Like, so if, for example, if we were to equate them, we would say x squared plus 2x plus 2 equals -x squared plus 2x plus 10. Okay, because that's where they intersect. So moving everything to the same side, because I can see that it's going to be a quadratic, I'm going to have 2x squared. The 2x's disappear. And then you've got 2 subtract 10. So that's -8 equals 0. So you've got 2x squared minus 8 equals 0. Well, I can factorize this. I can bring 2 out. So I've got x squared minus 4 equals 0. Are you with me? So then you've got 2. You've got, this is a, what kind of expression? Special. X squared minus 4.
Oh, it's the one that's like the same.
Yeah?
So it's like x minus 2 and then x plus 2.
Nice, Mally. Does anyone remember what that's called?
Complete.
Difference of two squares.
Yes, exactly. Okay. So because we've managed to get this expression here, we know that one of them is +2 and this one would be -2. Yeah. Okay. But as I say, however you solve it, enjoy. So the next step, we've got our 2 and we've got our -2. Remember, the bigger number goes on the top. We've then got this function, subtract this function. I've put this one in a bracket on purpose because you are subtracting everything here. Okay? So we've got -x squared subtract x squared gives us -2x squared. We've got 2x subtract 2x. Oh. We've got 10 subtract 2. 8. Okay? Here's our new function. Okay, so we've done our subtraction. Lovely, gently. We're now going to integrate this bad boy here. So we've got the -2x cubed over 3 plus 8x. Hang our limits. Lovely, jubbly. Substitute our values in. Superb. And we get this as our final answer. Okay?
So it's not going to be a number.
So,
It's not going to be a number.
yeah, it's a number.
No.
I've selected as an improper fraction.
Oh.
Really? Okay, find the area enclosed between the curve, blah, 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 blah. Right, so first, do we know where these things meet? So let's do that. What do we do?
Equate it.
Equate it. X squared minus 2x minus 3 equals x plus 1.
So then you want to bring out in there?
Yep. So right.
And that's going to be x. No. Wouldn't it not be? Oh, because it's minus. Yeah. No, because if you bring in the minus over. Oh no, you get to the x already from 2x.
Mm-hmm.
So then it just becomes x.
3x.
Minus 3x.
Got there in the end.
Yeah. Minus 3x minus 2. 4. Minus 4. Equals 0. And then you put like quadratic.
Negative here. We could quadratic equation it. Should we try and do factorizing? It's way quicker.
Okay. What happens to
Which numbers multiply to give -4 and to give -3?
2, 4, 8, 1.
Multiply to give -4. So 4 So that means that our two solutions are our two values are limit
Plus 4 and minus 1.
Okay, so we've got our limit. So now we're gonna draw our integral sign. We have 4 on the top, and we have a negative 1 at the bottom. We need to decide which of these functions is our g and which one is our x. This graph is a what kind of graph? Negative.
Positive. Positively
Positively
happy.
happy, so it's going to look like that. Because remember, you look at the sign in front of the x.
But then that was positive too.
Well, what kind of
That's a
What kind
line.
of graph is that?
Straight line.
Straight line, yes? Now, if there's an area between, you happy about that?
What's that mean?
Remember, it's a y equals mx plus c.
Uh,
Are you with me, sister? So if there is an area between them, then is my line going to be underneath here?
no.
No, it's got to be up here, yes? So that means that this
That is
is going to be our gx. Yes?
job, baby. You are high up to this.
So we're going to have x plus 1 subtract bracket x squared minus 2x minus 3 dx. Okay, so we'd be looking for this statement at some point in your working. If we didn't have it, then you may lose marks overall. You've got to be really careful because as soon as you've lost something on the mark scheme, if they can't allocate you a certain mark, you don't get anything after it. Okay. So here we've got x minus negative 2x.
X
X
minus
minus negative 2x.
So that's going to be X. Minus X? X.
So 1x subtract negative 2x.
So doesn't that become positive? So it goes up. So it's X. Minus X. Just an X. 0?
What is it?
I'm saying, yeah, 2X,
Plus
right?
2x.
So
So you
you've
do
got
2 minuses, it becomes positive.
So x
they're
plus
correct.
2x. X plus 2x.
Shut up.
3x.
Holy shit.
Okay, maybe no shutting up. Just thank you for the help, Natalie. Then we've got 1 subtract negative 3.
Check size for 1.
Minus 4. 2. I said
Minus
One.
negative 3.
it's the 1, so 2. Minus 2, 3.
1.
It's positive and a positive.
Negative away,
4.
adding.
Right.
So 1 plus 3.
4. That's what I said.
No, you said minus.
And then minus 2.
And then we've got negative in front of the x squared, so it's just negative x squared. Okay? With me, Anne?
Yeah. Why don't? Yeah.
I mean, obviously it's in a different order we used to, but it's fine. Huh?
Go to brackets.
Now we do, because we haven't actually done any integrating yet, have we? We've just been simplifying. So now we can integrate. So now this is where we square bracket it. So 3x becomes
3x squared over 2
yeah,
plus 4x d and minus it goes on to 50 minus x cubed over 3
Yeah.
close bracket. I mean, yeah, you do that.
okay, and then we're going to shove our numbers in, substitute them in.
Yeah. So wait a second, you're gonna have to yeah.
Oh, there you go. So 4 squared is
4 squared 16.
times 3.
16 times 3 is 56? Well, 16 and 16 is 32. 32 plus 16 is 48.
Nice. So it's 48 over 2. You were going to stop there, weren't you, Maddie? You weren't going to keep going.
Oh, you want me to?
No. So plus 4 times 4,
That's 16.
and then we've got minus 4 cubed.
4 times 4 is
32.
Isn't it the same thing?
33.
It's the same thing as what?
What is that? 16 times 4 is, I don't know.
Oh yeah, I don't know.
That's a calculator.
What's 10 times 4?
40.
And what's 4 times 4?
16.
And then what was 6
Six.
times? We're doing 6. What's 6 times 4?
56.
6 times 4 is 20.
What's 40 plus 24?
56.
40 plus 64.
Okay, so that's 64 over 3. Now, I'm only pursuing this because this could be on a non-cap paper, so we just need to make sure we can do this. So what's negative 1 squared?
No.
1.
That's what I mean.
Times 3. So we've got 3 over 2, and then we've got 4 times negative 1, so that's minus 4. And then negative 1 cubed.
So that's minus 1 over 3.
Yep, so then, but we're taking away that, so we're going to add 1 first. All right with that?
Oh
saying
boy.
Oh, so because it was a negative, I have negative as a positive. I'm fine.
Good.
So what's 48 divided by 2?
Well, what we could do here is because we've got like 48 over 2 minus 3 over 2, so they've already got the same denominator. So I could simplify this, but maybe it's just as easy to do this bit
I
here.
feel, oh,
So 48 over 2 subtract 3 over 2, so that's 45 over 2. Yes, you happy with that? And then you've got 16 take away negative 4. Come on, Maddie, you can do it. 16 take away negative 4.
twins.
OMG. We are flying. And then we've got 64 over 3 subtract 1 over 3.
So mine's 60.
63 over 3. Nice.
Oh.
That's a bit weird. So 45 over 2 is
2.5.
okay, plus 20, and then we've got 63 over 3. So let's 3's into 6 goes,
Twice.
and 3's into
21.
3. Nice.
Oh,
We're all on fire today. I love it.
so 20 and 21 is 41. Plus 3.5 is okay. That's the answer.
Yeah.
That's what we have to do.
Yeah.
No,
No, so this means that all. Well, we did quite a lot.
I think it's sometimes you sound more British than like normal.
What do you think?
Yeah. Like that was like when you just said a lot, it was like real British.
A lot.
No, it didn't sound like that.
What did I say?
It was like a lot.
Okay. So let's pause this.
I'm trying
You're-
to be that huge.
All right. So this is your screen. You know how to get to this screen?
Yeah.
Yeah. Okay. If you were at this screen here,
Yeah.
just calculate.
Calculate.
Okay. So then you press menu,
Menu.
and you see it says calculus.
Yes, ma'am.
Hopefully that's a clue that that's where we should be going. And we're trying to find the integral. Which one do we think we're going to go to?
Numerical
Oh,
integral.
honestly, there are no flies on you lot. Now, look at the screen. It looks just like the things that we've been doing, yes?
Yes, ma'am.
So, this situation here, you can actually input anything. So, let's think about what we just did, the example we just did.
2 and 4
So we
minus
had-
1.
X squared minus 2x minus 3 and x plus 1. So we found our limits were 4 and negative 1.
How
wasn't
you
it?
go back? Yeah.
So we're going to input 4
Oh, for
and input negative 1. Remember to use this button as the negative, not take away. Okay, so there's our negative 1. Now, if you are not very good at subtracting one function from another, you can just put the whole kit caboodle in as you see it. Okay? So we could type x. Now remember, your x, y, z, so your 3 main variables are down here at the bottom on white. So we could write x plus 1, subtract, open up a bracket, because we need to keep the other thing in bracket, x squared minus 2x minus 3, close brackets. Okay? So we've got our original function, subtract the second function,
Number 2.
and then we just have to fill in x here as well. Okay? So we've literally on our screen asked it to do what we would have done on the paper. Press enter, and there it is, 20.83 recurred there.
First of all, I didn't get that.
What did you get?
15.8.
Then we asked it this.
That's not the
What did you
answer,
get?
though.
I think you used it as an example.
Yeah, no,
You multiplied this.
Alright.
I put it in like Shasha got me to.
No, you're supposed to
Is
take
that
it away. You
66?
multiplied.
Is that supposed to give us the answer we already got?
Yeah, did we get that?
No.
What did we get?
63.5!
Oh, shit.
Unless I didn't get the... No.
I'm all on crack.
Wait.
Who's looking at the question wrong?
Nobody.
Did we really?
I think.
Yeah.
But just let's do it again. Yeah. Menu, calculus.
Let me do it.
Oh, smile.
What happened?
Bruh.
I don't know.
4
Ah.
minus 1.
Oh. E.
X
Well, let's start again then.
plus 1.
Menu.
Open bracket. What not? We take it away.
Was it 4 and negative 1?
Yeah.
Yeah.
We take it away.
Take away.
Maybe we did stuff wrong in our calculations. Maybe having a bracket here makes a difference. Is it x plus 1? Yeah.
Squared
X.
minus 2
How come I can't?
X squared
minus 3.
I got 20.8.
minus 2x.
Oof.
What did you get? What did you get?
We got -0.
Oh, we must have done something wrong in our calculations, Pete.
I got 20.83.
How did everybody get
There.
What happened?
Pete, this should have been minus.
I put minus.
Oh, shiver me.
Defo put minus.
Yeah, me too. Look, I corrected minus all the way
Should have
down.
been minus. So we have minus 64 over 3
This
minus
one,
1 over 3, so that was minus 64 over 3.
Make sure you get that on video.
I am, I'm recording it.
I definitely got
And
that.
so that makes this completely different. Apparently it makes it 20.83 recurring.
Wait, how is it?
So it's not 63.
No, it's not 63.
How is it minus?
Because this here, I just wrote plus incorrectly.
No.
But how is it minus, Miss Harrison? How is it minus
22.5 is
64?
that?
Oh, minus 65. Oh, far out, Brussels sprout.
Oh my gosh.
Harrison, seriously.
It's late.
Sorry, everybody.
Over 3? 65 over 3?
Yeah.
You snort crack.
Oh, not that.
That's minus 21.
So it's not 21.
It's what?
6 recurring.
What?
How does
So,
that work?
this here, so we want to change this to a fraction. You know you can do this, bad boy, convert to prop. So it's 125 over 6.
That's the answer, 20?
Yeah, 125 over 6.
No. Leo, what did you get as the answer for the... What is 65?
Okay, are we happy with that?